In this video, I'm going to explain variation between two charge. So we take the case of 2-point charge as shown in the diagram here, charge A and B, separated by 6 cm, and D is taken from A. And the graph below here shows you how the field strength changes. Okay, so for convenience, I'm going to shift the point A and point B down here. So before we look at how the graph combine and become like this, we're going to look at the few lines of A and B. So let me draw that first. Okay, so let's say charge A is positive and charge B is negative. Definitely this case, if you look at the graph below here, it is two opposite charge. So we are saying that charge A is positive and charge of B is negative. That's why the arrow is pointing out from A and pointing in of B. Okay, so further on, if I were to draw how the field strength changes as it moves away from A, and how the field strength as it change from B. So then I'm going to draw some vectors. So with the vectors shown extending from A and B along the line AB, I have added some arrows to indicate them. You can see that the arrows is getting smaller as it move away from B, and the arrows of field lines of B also getting smaller as it move away from B. So overall, if you look at their direction of those arrows, they are actually pointing in the same direction. So let's say we are taking to the right as positive, then the whole graph as it combines is supposed to be a positive value. If the arrows is pointing to the left due to the difference in the charge, then our graph will be in the negative region. If the two charges are same, then you should expect that B will point opposite to A. Then the graph will go across from a positive region to a negative region. So probably I will explain that in another video, but today let's look at these two positive and negative charge. So if you were to draw the field strength of A, then it should look something like that. As it move away from A, and for B it will be something like that. Okay, so the combined graph is actually the addition of these two values. So let's say we are looking at this point. So this point is basically the value of field strength at this point, and the value of field strength of B at this point. If you add them up, EA and EB, so if you add them up, EA plus EB, that will be basically the value at that point. So if you work out all the rest, that should give you a higher value. Alright, so then you might be asking, how if the charge A and B, they are sphere? So if they are sphere, the graph would not be very much different, because we know that field strength inside a sphere is 0 due to the electrostatic equilibrium achieved. Therefore the graph will only start at the surface. So if I were to draw the sphere A and B as a sphere, hold on. Alright, you can see that I've added on if it is a sphere of A and a sphere of B of a certain size, and then in the graph below there, so I have extended the 0 right from the center to the surface, and also for B right from the center to the surface. So there will just be 0, and the variation of the field strength outside is still the same, it's still decreasing. That's basically, if I forget to explain just now, that's basically due to the fact that field strength is directly inversely proportional to the distance squared. So that's why both of them also decreases in an exponential way. Okay, so hope this helped.